like the poll is closed. So I'm going to drive the slides while Kevin is on the road. Thank you for joining us, Kevin. Again, from the National Weather Service, the River Forecast Center, based out of Kansas City. He's one of the river and flood forecasters for the Missouri River Basin. So he'll give us our flood outlook for this season. Go ahead.
All righty. Thank you. All righty. Thank you, Laura. Can you hear me okay?
Yep, we can hear you just clear. Yep.
Perfect. All righty. Well, I wish to thank Laura again for inviting me to speak in this year's Crop Hour series. Again, I'm Kevin Lau, and I'm with the National Weather Service, but I'm with the River Forecast Center down in Kansas City, and we have responsibility for real-time river forecasting for the Missouri basins, and that, of course, is the area that is shown there in navy blue on my intro screen. And we cover all but just the very extreme northeastern portion of your state. And again, glad to be with you this morning. Today I'll be providing the latest with regard to the 2023 spring flood outlook for the entire basin. Won't just be concentrating on South Dakota, but for the entire basin this morning. We have been already issuing spring flood outlooks. We issued our first one on Thursday, February the 9th. And then we issued our second one. We issued an update last Thursday on the 23rd of February. And then we will issue our third and our final update next Thursday, not in 2 days, but in 9 days on March 9th. And that will be our third and final outlook before going into the forecasting season. And you can read our outlooks and look at our outlooks by simply Googling our initials, MBRFC, for Missouri Basin River Forecast Center. So just Google that, and it's a headline on our front page, and you can read what we're thinking is going to happen with regard to river flooding across the entire basin this year. Now, the National Weather Service headquarters, they will also issue a spring flood outlook for the entire nation, and that will come out on March the 16th, and that's a Thursday as well. So on March 16th, headquarters will issue an outlook for the entire U.S., and you can simply Google National Weather Service Spring Outlook, and you should be able to land on that page around noon on the 16th of March. So go ahead to the next slide there, Laura. I'll start off by saying that there is an overall normal to reduced from normal or lower than normal flood risk for the Missouri Basin this year. And over the course of the next few slides, I hope to give you the reasons why we think it is going to be a normal to a reduced from normal flood risk. On this first slide, on the right-hand side, this is sort of the basis for how we come up with our outlook. We forecast or we monitor about 430 locations across the basin, and those 430 some odd locations are depicted as dots on this map. It's kind of hard to read the dots, but every month and every 2 weeks during spring outlook, so every 2 weeks during February and March, but every month throughout the year, we issue a long range river outlook. And this long range river outlook, it takes the period of record temperatures and period of record precipitation, and we go back 30 years, and we run 30 years of data through our model, creating a hydrograph given today's conditions. So we'll take today's conditions, our soil moisture, our snowpack, and we will run 1991 temperature and precip through that for the next 90 days. And then we'll run 1992 temperature and precip for the next 90 days, so forth and so on. So we'll be creating 30 hydrographs or 30 outcomes based on today's soil moisture, today's snowpack. And that comes up with 30 hydrographs, and we slice and dice those hydrographs and come up with the plot that you see on the right-hand side. And we do that for all 430 locations that we forecast. Now, the plot on the right is for the James River at Scotland. And so what you see on this plot is that the black line is the probability distribution for today's conditions. And what we like to key in on is what is the chance this year of this location hitting minor flood stage. And minor flood stage for Scotland is 13 feet. So we see that this year we have a 32% chance of hitting minor flood stage. Now, historically, if you look over the period of record, historically, Scotland has just less than a 50% chance of hitting flood stage for the springtime, for the next 90 days. And so this is how we come up with the, this is the reason why we say that for much of the basin, we have a reduced risk or a reduced likelihood for flooding, is because the black line, today's line, is shifted to the right of the historical. And so looking at the map on the left, anywhere you see blue dots or blue regions, that means that this year we have a reduced risk anywhere from the blue line. The blue regions are -10 to -30. The deeper blue, the navy blue splotches you see on that map on the left, those locations have anywhere from a 30 to a -50% reduction in flood risk for this year as compared to normal. So that's a lot of rambling to say that for all those blue areas, we have a reduced risk for flooding. It doesn't say that we don't expect flooding there or that we do expect flooding there. It's just that's the percent of reduction. Now, you'll notice there are a few areas, and for the state of South Dakota, you notice that the Vermilion in the southeastern portion and the Big Sioux, the upper reach of the Big Sioux, we're talking Watertown area, Castlewood, anything upstream of Brookings, it has an enhanced flood risk this year as compared to normal. That doesn't mean it's going to flood or not going to flood. I'll get to that in a later slide, but the percent chance of reaching flood is higher for that area. And that's because of the snowpack that we have, and also maybe a little bit of frozen ground in there, which I'll talk to that here in a minute as well. We also see that the North Platte over in Wyoming, it has an enhanced risk. And we also see that the Bighorn River there in south central Montana has a bit of an enhanced risk this year. So there are places where we're expecting a higher risk for flooding, but overall we have a normal to below normal. So I'll go ahead and go to the next slide then. And soil moisture, and Laura did a fine job going over that. The Missouri River is entering its third year of drought. Water years 2020, 2021, and 2022. That covers the period from October of 2019 to September of last year. Those 3 years were the 10th driest 3-year stint on record. So those 3 years are the 10th driest 3-year stint on record for the Missouri Basin, going back 125 years. So we're still in a drought for most of the basin. For the Missouri River Basin, I think the latest drought monitor that came out last Thursday, and it should be updated in 2 days, but it showed 60% of the Missouri Basin still being in some category of drought. And Laura already went over for South Dakota. So we're still dry, and these two images here just bear witness to the fact that the soil moisture models are still indicating that much of the basin is still much drier than normal. And that will play in, of course, to the flood potential risk. Going to the next slide, frost depth is a significant factor in predicting our flood risk. If the ground is deeply frozen, then any runoff produced by spring rains or melting snow will enhance the runoff capability if the ground are frozen. But as As Laura mentioned, oh, and I want to say that the South Dakota Mesonet is, you have a wonderful site. I really like um, the poker chip, I think is what the lower right-hand graphic is sometimes affectionately known as, but I love the graphics that your state Mesonet puts out. It's really helpful um, for what we do in our office. But as Laura said, we believe that for most of the basin, frost depths are shallow or non-existent. And a couple of reasons for that. Number one, just the really dry soils. The moisture there's not the moisture in the soils going into freeze up that would allow the soils to become locked in place like concrete. And as Laura mentioned, those locations that this year luckily have a deep snowpack that helps to insulate the ground as well. So for the basin as a whole, we are believing that frozen ground is not going to be a significant factor in runoff enhancement for this season. So going to the next slide then. So looking at the mountain snowpack is very important for the Missouri Basin. I usually say that Mount Snowpack accounts for about 30% of the annual runoff for the entire basin. So it's very important for our office in looking at flood potential to look at the snowpack in the mountains. This graphic is courtesy of the Natural Resources Conservation Service, and it depicts the amount of snow water equivalent or the amount of liquid in the snowpack in terms of percent of average. That's what I use here. You can also go to this website and do percent of median. I like to look at percent of average. So mountain snowpack for this year can be categorized generally as being near normal. And this is a good thing. With the exception of the North Platte. Now the North Platte has what I would say would be a above normal snowpack for this time of year. Don't the Milk River up there at the Canadian border, that I think that's overdone, and that's because it relies on only a couple of instruments, and so I think it's a bit overdone. So I'm not too concerned about the mountain snowpack in the Milk. But generally in the mountains, I would say we're near normal, with the exception of the North Platte, where we are above normal. And we are about 80% of our way through the peak seasonal snow water equivalent accumulation period. So we've still got about 20% of the time to build more snow. But if things stay on track, then we're going to have a normal mountain snowpack this year. So with the next slide, we'll see what that normal to maybe slightly above normal mountain snowpack means with regard to runoff. So our office does what's called a water supply or a volumetric outlook for the time period April through September. So that's what these colored dots represent, is the percent of normal volume that we expect the mountain snowpack to produce as far as runoff goes. And even though we have a near normal mountain snowpack, we're not going to have a near normal runoff. We're going to have a below normal runoff, again, due to the ongoing drought that we're having. So those are, so we do about 50 locations, I think. And I just took one, what I consider to be a key location from each of the four basins, and gave you the statistic there on the right-hand side. Now the North Platte does have about 120% of snowpack, and we are expecting about 120% of runoff in the North Platte down at Seminole. That's going into Seminole Reservoir. And as I'll get to in a later slide, we are forecasting minor flooding along the North Platte River due to the snowpack in the Wyoming area. I don't expect this to translate down to the Platte River in Nebraska, so I'm not concerned about that. But I think we do have a good shot at seeing some minor flooding in the headwaters of the North Platte moving into late May, early June. So the overall take-home point here is that a normal mountain snowpack is not going to significantly increase the flood risk for the basin. Okay, next slide, please. So plain snowpack. Again, as Laura mentioned, we've got a healthy snowpack in the eastern portion of South Dakota, and we have a healthy snowpack across much of North Dakota, and that will play into flood risk, but it's really a good thing and not a bad thing. It's not going to result in significant flooding, I don't think, but it's going to be more of a help than a hindrance. So let's go then to the next slide. Okay, these are just a couple of different views of what the snow means in the plains as compared to normal. So on the left-hand side, this is courtesy of the Midwestern Regional Climate Center. And I just accumulated the snow from October 1, what we call the beginning of the water year. And you can see that we have a significantly greater amount of snowfall since October 1 across the northern plains. The right-hand side shows kind of the same thing. Our remote sensing office up in Minneapolis, they run a snow model that is separate from the snow model that we run. So this is modeled information here on the right-hand side. But basically, it's showing that for the plains region, we do have a higher or above normal snowpack in terms of snow water equivalent, the liquid that's in that snowpack. We've got a greater than normal snowpack in the northern plains. Okay, so the next slide. Okay, so this is where, this is why Laura had me come on, is this is the real answer, or our best answer anyway. So these are the areas that we do expect flooding to occur this coming spring. So along the North Platte, again, we're expecting some minor level flooding based, primarily on the mountain snowpack being above normal. We do expect minor flooding along the North Platte there in Wyoming. We are expecting the James River in South Dakota there to have a couple of locations, Columbia, Stratford, that kind of locations that will see minor flooding this spring. We are also looking at the Big Sioux having minor to moderate flooding. Now, when I was putting this all together yesterday, I was looking at our model, and we've got what may be too much of a frozen ground factor in our model. So between now and next week's outlook, I'm going to be re-looking at the amount of frozen ground we've got in the upper Big Sioux. And again, that's Watertown, Castlewood area. Vermilion, also looking at minor to moderate flooding in the Vermilion in South Dakota. And then in Iowa, northwest Iowa, we've got a healthy plain snowpack there too. And we are predicting or projecting minor flooding along the Little Sioux, the upper reach of the Little Sioux this coming spring. And then the lower basin, I could have put this forecast out 10 years ago. We always have flooding in the lower basin, driven by thunderstorm activity. Laura mentioned thunder, as we're getting later and later into the year, thunderstorms are, the potential for thunderstorms are now creeping into our outlook period. And so we're expecting minor to moderate flooding across much of the state of Missouri and eastern Kansas. Again, this will be episodic, on again, off again, due to isolated or individual storm tracks. The Missouri River itself below Kansas City, I suspect we'll see 2 or 3 locations between Kansas City and St. Louis along the main stem going to flood. As we go later into the summer, July or June, early part of July, I suspect we'll have some flooding on the main stem Missouri above Kansas City as well. But that's kind of getting out of our spring outlook and into the summer outlook. But and again, that's all driven by thunderstorms. So with my next and last slide, I think, so here's some just brief take home points. Overall, spring flood risk across the basin as a whole is lower than normal. Mountain snowpack is close to average, and we still have, oh, I should have changed that. We have about 20% of the snow accumulating period left. We're 80% of the way through. We've got an appreciable plain snowpack over portions of the Dakotas. The soils, though, are very, very dry. They may be cold, but we think they're still porous and they can accept melt and they can accept spring rains. Ice jam breakup flooding is low. I didn't mention ice jams in my talk this morning, but where we do have ice, I mean, as long as we've got ice in the rivers and snow on the ground, the risk for breakup flooding is there, but we think that it is low for 2023. Flood potential in the mountains is limited to the North Platte. In the northern plains, we're looking at James, Big Sioux, Vermilion, Little Sioux. And in the lower basin, it's a crapshoot. We're sure to have flooding along the minor tributaries in eastern Kansas, across Missouri, and the Missouri River itself downstream of Kansas City. So I think that's about it. So I guess bottom line is that I'm thinking that we're going to have a bit more active year this year than last year. But I'm not foreseeing any significant widespread systemic flooding to affect our basin. All righty, back to you, Laura.